All right, lesson 82. We are graphing the sine and cosine functions today. All right, first to graph y equals sine x. All right, there are a few things that you can do here. First of all, with any graph, you can always make an xy chart. So if you want to grab that calculator and start plugging in some points, if I plugged in 0 for x, I would get 0 for y. If I plugged in a half for x, sorry, not for x, if I plugged in a 30 for x, I'd get a 1/2 for y. Alright, say I plugged in a 60 for x, I believe you'd get 0.87 for y. If I plugged in a 90 for x, I'd get 1. 120 for x, I'd get 0.87. 150 for x, I would get 0.5, 180 for x. I would be back to 0. So then the question would be, well, it looks like there's a pattern there, and there is in both sine and cosine graphs. Is it going to follow what I see here? Is it going to do something different? Well, if you plug in a 210 for x there, sine of 210, we get a negative 0.5. 240, we get a negative 0.87. And then you might go and say, well, that's the same pattern that we have here, it just reversed. Instead of being positive, and it's negative. And you would be right with that. So we've got 0, 0, 30 and 1/2, 60 and 0.87, so about there, 90 and 1, and then so on. All right. Now this is one way to do it. All right. And remember, I told you earlier in the year that you can always do an XY chart. It is not always the fastest way, but it does work because when we connect the dots here, we do end up with our sine graph. Now do realize that this graph goes on and on in each direction, going both ways, so we do have to put arrows on there, but sine is an oscillating graph, meaning it will oscillate between 1 and -1 for as long as it goes. All right, we could do the same thing for cosine. All right, so if we did an XY chart here, and we put a 0 in for cosine, cosine of 0 would be 1. Cosine of 30 would be 0.87. 60 would be 0.5, and you're probably already going, all right, I know the pattern. All right, and it is the exact same pattern. Right, 90 is 0. 120, well, we came down from the positive down to 0, so then we're going to go negative. And we just keep going with this. And you could do this for every single point on the graph. So we've got 0, 1, 30, 0.87, 60, 90, 120. Now, interesting thing about cosine compared to sine is, first of all, it is the exact same graph. Right? It may not look like it right now, but if you put them side by side, and especially if you expanded this, so instead of from 0 to 360, it was like 0 to 1080, you would see the exact same graphs. They would just be offset, and they'd be offset by 90 degrees. All right, so you might be going, well, is there a shorter way to do this problem? And the answer is yes here. All right, first of all, you need to find the amplitude, the number of cycles, and the period. The amplitude is the absolute value of your A value. A is the number out in front of sine. The number of cycles in the interval from 0 to 2 pi or from 0 to 360 is B. It all depends on if you're in degree mode or in radian mode. Okay, so this b value is the number out in front of the x, in between your sine or your cosine and your x value. That tells you how many cycles, that tells you how many waves you have between 0 and 360. And then the period, how long is one of those waves? You take 360 divided by b, or 2 pi divided by b. Alright, most of the time we're going to do the degree measurements just because it's a little bit more, it's easier for you guys to understand. Alright, so find the amplitude and cycle of each one of these. Amplitude, the number out in front. So we can go through every single one of these and do these really quick. If you pay attention down here at the bottom, remember amplitude is always positive, so even though this is a negative 10 down here, that turns into a positive 10. Cycle. Alright, cycle is the number out in front of x. So if there's nothing there, it's a 1. This next one, we have a 2, and another 2, and down here at the bottom is a 4. And then the period, we take 360 divided by our cycle. So 1, so our period here is 360. Period here, 360 divided by 2 gives us 180. Period here, 360 divided by 2 gives you 180. And down at the bottom, 360 divided by 4 gives us 90. Remember, the amplitude is telling you what that measures is it's measuring from your center point of the graph, from the center to the top. How high does it get? So this bottom one, if it started at 0, the top would be 10. All right, the cycle tells you how many waves are between 0 and 360, and the period tells you how long each one of those waves are. So let's try a few of these. Graph y equals negative 4 sine of 3x. Now, what I have come to realize is probably one of the easier ways to do it is do not graph this first. Graph negative 4 sine of x. Alright, so for sine, we start at 0. Alright, and here's some of the shortcuts with this. Sine always starts at 0, it always ends at 0 when the period is 1. Halfway in between those two, it's also going to be at 0. Halfway in between those two, so 0 and 180, is going to be whatever your amplitude is, or whatever the number is out front. So that would be down at negative 4. So at 90, we'd be at negative 4. For 270 then, well, remember, this is a wave. This would go up to positive 4. All right, so 4 sine of x would be approximately that. And that's not what we're graphing though, is it? You can leave this on your paper. We're just going to use this to be able to tell what we need to do next. All right, the only difference between this graph and this graph is that 3. And how we deal with that is every single one of these points, so all 5 of those points, we're going to divide the degree measurement by 3. And that's where our new point is going to go. So 0 divided by 0, or 0 divided by 3 is 0. 90 divided by 3 is 30. 180 divided by 3 is 60. 270 divided by 3 is 90. Now notice the y values are still staying the same. We're just shrinking this graph. 360 divided by 3 is 120. Alright, so if you look at this and connect those dots the best you can, there's one wave. It's the same wave, it's just shrunk. Alright, and then you just follow the pattern from there. So we're at 0, we're going to come down here to negative 4, we're going to come back to 0, we're going to go up to 4, come back to 0, and down to 4, negative 4, and then back up and then to the top, and then back to 360. So then we just connect our points. Okay, and there is our graph. And I'll be able to tell that your blue graph is actually your line that you're trying to graph there. All right, so that's sine. Remember, sine starts and ends at 0. Halfway in between is at 0. Halfway in between those two are either at your topmost point or your bottommost point. Halfway in between the other two are the reversal. So if it was the bottom point, it becomes the top point, and so on. All right, cosine is just a little bit different. I would still do the same thing though. Y equals 3 cosine of x first. Now remember, cosine starts at its highest most point, so we'll say that's 3. And it goes to its bottommost point, which is -3. And how this works is it starts at 3, it's going to end at 3. Halfway in between those two though, it's going to be down at -3. Halfway in between those, 90 and 270. And then we connect the lines best we can. And there's our 3 cosine x. Difference between the two though is this 2. All that means, take every single one of these points, the degree measurement, and divide it by 2. So 0 divided by 2 is 0. 90 divided by 2, 45. 180 divided by 2 is 90. 270 divided by 2, 135. 360 divided by 2 is 180. And then we're back up to the top, meaning the pattern is going to repeat. So we're going to come down here, okay, because if we look, this advances 1.5 squares there. So we got to come over 1.5 squares, and then we come down another 1.5, and back up, and to the top. And there we go. That blue line, once again, is our graph. Now this is just the introduction to this. I don't expect you to have these absolutely perfect by the end of this first time, but we are going to see these quite a bit as we go forward here. So definitely work at it. I will be back on Thursday to be able to answer questions for you.